Let's look at three more problems evaluating our trig functions, the cotangent, secant, cosecant, um, using our nice special angles around the unit circle. Okay. So again, some things that we're going to think about is where are our values positive or negative? We know all of them are positive in the first quadrant. We know sine and cosecant are positive in the second. We know tangent and cotangent are positive in the third, and then we know cosine or secant are positive in the fourth quadrant. We also need to know our first quadrant of the unit circle, so we need to know the 0, 30, 45, 60, and 90 degree angles and their corresponding coordinates on the unit circle. And we're also, again, going to use some of our fundamental identities, particularly the reciprocal identities. Okay, so, and we worked through similar examples in the previous video. So we're just going to do a few more here. So let's start out with the cotangent of 135 degrees. We may have actually looked at this angle before already, but that's okay. So we're going to start with drawing and locating that angle. So you don't have to draw it every time, but you do need to locate it in your mind if you need to know where it's at. So 135 is between 90 degrees and 180 degrees, right? So it's right there. Okay, so this is 135 degrees. Oops, 135 degrees. And we need to find its reference angle. So the distance from 135 to 180, if we subtract that, we're going to get 45 degrees. So 135 degrees is in the second quadrant, and it has a reference angle of 45. Okay, so let's try to now look at the cotangent of 135. So one of the identities we can use is we know that cotangent of theta is equal to the cosine of theta over the sine of theta. You could also use that cotangent as the reciprocal of tangent, but this gets more directly at what we're trying to do here. Okay, so we're going to rewrite the cotangent of 135 degrees as the cosine of 135 degrees over the sine of 135 degrees. Okay, and then we're going to jump from 135 degrees to our reference angle. So cosine of 45 degrees and sine of 45 degrees. But when we do this, we now need to apply the sign, whether it's positive or negative, for each of these. So cosine is an x-coordinate, which means it is negative in the second quadrant, right? Only sine is positive in the second quadrant. So we're going to have cosine is negative, sine again is positive. So we're going to have a negative cosine of 45 degrees divided by a positive sine of 45 degrees. Now we can jump to using our unit circle. So we find our 45 degree angle, and we need to look at the sine and the cosine. So remember, cosine is the x and sine is the y, which they're the same values this time, which is nice. But so we're going to have a negative, and the cosine of 45 is a square root of 2 over 2. And we're going to divide that by a positive square root of 2 over 2. And everything sort of cancels out, right, which is nice. And so all we're left with is a negative divided by a positive. So the cotangent of 135 degrees is equal to a negative 1. All right, let's try a secant of 5 pi over 4. So again, we'll locate where 5 pi over 4 is at. So 5 pi over 4, we're going to go around the unit circle. We know here's 1, 2, 3, 4, 5 pi over 4. So 5 pi over 4 is in the third quadrant. And its reference angle goes back to the x-axis, and it's just a distance of pi over 4. So we know we're in the third quadrant. We have a pi over 4 reference angle, and so we just need to apply our identities. So secant of theta is the reciprocal of cosine, so 1 over cosine. All right, and cosine, we can go ahead and jump on this. Cosine is negative in the third quadrant. Okay, so put all that together. We have secant of 5 pi over 4. We could use that reciprocal property and rewrite this as the cosine of 5 pi over 4. And then we could use our reference angle. So the cosine of 5 pi over 4 is a cosine of just pi over 4. But because, again, we're in the third quadrant, cosine is negative. So it's really 1 over the negative cosine of pi over 4. And then if we find pi over 4 in our unit circle, in our first quadrant, and we look at the cosine, which is the x value, it's root 2 over 2. So we are going to have 1 over a negative root 2 over 2, which we can do the reciprocal of that, which will give us a negative 2 over root 2, which you could leave it there if you want, but we could also rationalize this by multiplying top and bottom by a root 2 over 2. And then when we do that, we end up getting that secant of 5 pi over 4 is a negative square root of 2. Okay, that's because, again, this becomes a 2 root 2 over 2, and the 2's cancel. All right, last one here. Let's do the cosecant of 3 pi. So again, same process. Let's draw out our angle. So 3 pi, this one's a little different, right? It's not a fraction, it's just a whole value of pi, which might be confusing, but it's actually quite easy. So again, we're going to track around the unit circle, and each half of the circle is pi, or is a distance of pi. So 0, we track the entire top half of the circle to the negative x-axis, and that's 1 pi. The whole bottom of the circle is now 2 pi. And then we go around the top half of the circle again, and we end up at the x-axis for 3 pi. Okay, and we can keep going, right? We're just adding halves of the circle each time. So 3 pi is actually a point on the negative x-axis, which means it's a quadrantal angle. And I don't actually have that point listed on my graph here for the first quadrant. Although it would basically be the same thing as our 0 degree angle, which is the coordinate 1, 0. But it is actually going to be, since it's on the negative, it would be a negative 1, 0. Okay. So to figure out what cosecant is, again, we want to use our identities. We know that cosecant of theta is the reciprocal of sine. So cosecant of theta is 1 over sine of theta. So that means that we have cosecant of 3 pi would be equal to 1 over the sine of 3 pi. Okay, we're not in a quadrant. We are actually on a quadrantal angle, so I don't need to worry about reference angles or anything like that. I just need to know which of the points on the axes are we on, right? We're at the point negative 1, 0. So we're at negative 1, 0. And remember, sine is the y coordinate. So I go from 1 over the sine of 3 pi to just having 1 over 0. And you might get that and pause for a moment, and you should, because what is true about 1 over 0? What is that? Well, it turns out that that is undefined. So the cosecant of 3 pi is undefined. That's okay. All right. So of all of our functions, sine and cosine are always defined. You will always get a number for sine and cosine, because sine and cosine are just equal to the x or the y coordinates. But tangent, secant, cosecant, and cotangent, they are all reciprocals in some sense. And so they are all going to have, or they're all fractions in some sense. And so they are all going to have places around the unit circle, angles around the unit circle, where they are going to be undefined. And that's okay. We just have to be ready for that and be familiar with it and recognize when it happens. All right.